In this episode of KubeFM, Tanat discusses the engineering decisions and operational challenges behind managing SHIP, which is Adevinta's internal multi-tenant Kubernetes platform we spoke about in a previous episode. Tanat walks us through their shift from blue-green to in-place upgrades on EKS, the impact of cluster scale, and how they optimize for SLOs during full node pool rebuilds. We explore how his team built custom dashboards to surface deprecated APIs using tools like Pluto and Prometheus, enabling safer upgrade cycles across teams. Tanat also shares hard-earned lessons on configuring pod disruption budgets, warming up ELBs in advance, and using canary clusters to mitigate production risk. Conversation we had also covers emerging tooling like vCluster for multi-tenancy, Carpenter for cost-efficient autoscaling, and the use of eBPF via Cilium and Hubble. If you're responsible for Kubernetes operations or platform stability at scale, this episode offers pragmatic strategies rooted in real production experience. This episode of KubeFM is sponsored by LearnK8s. Since 2017, LearnK8s has helped engineers all over the world level up through in-person and online courses. Courses are instructor-led and can be taught to individuals as well as to groups. Students have access to the course materials for life, and courses are 60% practical and 40% theoretical. For more information, check out learnk8s.io. Now, let's get into the episode. Well, Tanat, welcome to KubeFM. What are 3 emerging Kubernetes tools that you're keeping an eye on?
Yeah, so the first one in my list right now that I'm keeping an eye on is KRO or Crow, which is a new emerging open source from AWS. It stands for, I think, Kube Resource Orchestrator. And well, as a platformer myself, I see great benefit from using KRO. For example, you can provide an easy abstraction layer on top of Kubernetes APIs, and you could define dependencies among them. So this could be super useful to simplify your platform operations and, enhance the developer experience. And probably the second thing would be vCluster or virtual cluster, because also as a person that run the multi-tenancy Kubernetes, and the problem that we usually face is that some people rely on the same CRD inside the same clusters, and we want to upgrade version for one, and then it will conflict with another. So vCluster could be used to kind of provide the isolated view of Kubernetes for each of them. And I also experiment with some kind of development speed up so that we can spin up the new development environment quickly. And probably the last thing would be anything related to eBPF, because I'm personally using Istio ambient mode myself, but I keep an eye on things like, Retina or Cilium or Hubble in that regard. Yeah.
Now, just for sake of intro, who are you? What do you do? Where do you work?
So my name is Tanat, and I'm originally from Bangkok, Thailand, but now I'm living and working in Barcelona, Spain, with a company called Adevinta. So we do things like digital marketplaces around Europe. So yeah, that's what I do now.
And how did you get into cloud native?
Well, I think I started my career as a software engineer, and I think around like 2017, my company at the time, they started to have this kind of a POC project that play with cloud native applications, throw factors, all those kind of things. And I like jumped right in and say that I volunteer for this. And yeah, the first platform that I work with is actually Red Hat's OpenShift. And yeah, I think I still remember the first OMQ error that I faced the first time that kind of kickstarted my career in cloud native. And yeah, after that, there comes Terraform, there comes Kubernetes and everything. Yeah.
Now, the Kubernetes ecosystem moves very quickly. How do you stay updated? What resources do you use?
I think it's almost impossible to keep with the fast-paced industry like this. But I think most of my my go-to sources are my LinkedIn network. I try to connect with a lot of people. When they share something, they react to something, I see interesting thing comes up, and that are my sources. Also, I think I have a few of my favorite sources, such as KubeFM, of course, one of them, and Learn Kubernetes, and also a few publications such as SRE Weekly and the Pragmatic Engineer are very good.
Thanks for the compliment. If you could go back in time and share one career tip with your younger self, what would it be?
I would totally write more blog posts because ideally, when you want to write about something, you have to understand it clearly. So you have to contemplate it. You have to think about the core idea of what you want to write, and that kind of teach me a lot on the topic that I want to write about. And also, it's a plus that it also give you exposure, right? Sharing more blog posts. So yeah, that's my recommendation.
As part of our monthly content discovery, we found an article that you wrote titled Unpacking the Complexities of Kubernetes Upgrades Beyond the One-Click Update. So we're going to talk about this a little bit more in depth. It's also a subject that's come up on other podcast episodes that we've done, so we know there's a fair amount of interest in it. Can you tell us about the Kubernetes platform you run at Adevinta and what your team is responsible for?
Sure. So the platform that I'm working with is called Ship. I think it was mentioned before in the previous episode with some of my colleagues. Well, to refocus, Ship is the internal Kubernetes platform as a service. It's being used within Adevinta, and it is designed as a multi-tenancy by default. So it means that a lot of developers team share the same underlying Kubernetes clusters, but they have their own kind of isolated namespace to work with. And my team is responsible for taking care of everything about Ship, so including maintenance, upgrades, adding more features, and also on-call support. And yeah, the thing that triggered this blog post was that I think around 3 years ago, we decided to transition from using a tool called AWS, which is a command line tool to provisioning Kubernetes cluster on AWS. I think it's the official tool. But then we decided to transition away to managed service like EKS. And I think there are two main drivers for this push, right? So the first one is that AWS was at the time being deprecated already, and it kind of stopped at Kubernetes 115. And I think at the time the upstream already went to, I don't know, 119 or 120. So that meant that we were missing a lot of critical features. We were missing a lot of security patches. So thing like volume snapshot, a thing like ingress class, we were not able to use it because we were stuck in 115. And additionally, I think there are a lot of components that we install inside our clusters that stopped supporting older versions. So it means that we were stuck with the older versions of every component in the cluster. So we were missing out the feature, we were missing out the bug fixes in everything. And I think the second driver was that we want to shift our focus as a team toward more higher layer of the stack, which means that we want to provide features to ship users instead of doing all the infrastructure management. Because with Kubernetes, even though it's kind of a tool, but we had to manage everything. So it helped us create etcd cluster, it helped us create API servers, but we are the one who has to take care of them. So I think 3 years ago, we faced a lot of like critical incident around etcd not being healthy, API servers not stable. So we spend a lot of time fixing them and spend a lot of time monitoring them. So yeah, by moving to EKS, we let AWS take care of everything underlying infrastructure, so the team can focus on building whatever on top of Ship. And I think the last note that I want to mention here is that it's not all bad that we used to manage etcd, even though it bring focus less focus to the product. But having a chance to fix etcd and API servers issue was kind of an experience that I still take away, and I still have it at hand when something go wrong. I know how it works. Yeah.
Cluster upgrades seem to be a significant challenge at your scale. What problems were you facing with upgrades, and what strategy did you initially use to handle them?
Yeah, so in the early days, when we had just a handful of Ship users, we went for the strategy that is called blue-green upgrade. And this meant that providing like provisioning a brand new cluster empty, and then we slowed with the updated version, of course. And then we work with the development team so that they start deploying the same workload in the new cluster. And then they can ensure that everything works. Before we started to shift traffic over from the old cluster to the new cluster gradually, it's like 5%, 10%, and keep going on and on. And this was kind of a safe method because first the team would verify first if the application could work with the new version properly. But the problem was that once our user base grew, so this approach become kind of unsustainable. This being that each migration required like a high coordination between our team and our user. So we have to schedule a maintenance window with them every team. We have to pre-create the new cluster, and we have to work with them like hand in hand to slowly shifting traffic. So yeah, this migration normally took months to finish the whole upgrade, and it consumed the whole quarter for us to just do one upgrade. And I think this situation was getting worse when we moved to EKS, because as you might know, EKS version come with the kind of expiration date. So once you got into EKS, each version will last only 13 months before it become end of life. So this kind of add pressure for us, and we always have to run against the clock on this.
You mentioned that scale became a significant challenge in your upgrade process. What specific scaling issues did you encounter when migrating between clusters?
So yeah, one of the, I think, hidden complexities of the blue-green approach that maybe people listen to it and think that, okay, this sounds good on paper, but actually there is a problem that we call scale mismatch in this regard. So I would think of every Kubernetes cluster, we have like a living organism or living system. So it means that it evolved over time through auto scaling and organic growth of the traffic. And then if you spin up a brand new cluster, it starts from zero, right? It's empty a cluster, but the existing one already have a lot of like mature traffic, mature workload, and it's optimized to the real world workload. So in order for the new cluster to mature at the same stage, it requires a lot of cycle of auto scaling and a lot of restart. So it introduced noises from the migration to the users. So for example, ingress controllers in the old cluster are ready, so they are scaled to handle production workloads, while the new one need time to warm up. Also, thing like Prometheus, where in other cluster, it is already scaled based on number of pods, number of objects in the existing cluster, and it might be as big as 80 gigabyte of memory, while the new one is running with a few gigabyte. The real problem was that even though we have everything ready to be auto scale, so we have thing like vertical pod auto scalers, we have thing like horizontal pod auto scalers, which in theory, eventually the cluster will have to mature automatically without any intervention. But this process normally takes small increment. So each cycle bumped it 20%, 20% until it reached to the mature stage. So yeah, this bump introduce some noises to our user. So it's not as good as in paper. And some additional note is that even cloud provider itself need time to be warmed up as well. So I remember that I have to submit some kind of a request to AWS to warm up the Elastic Load Balancers in advance before migration, just to be ready to cope with the same traffic in the old clusters. And I think not only the scale problem, but some kind of application are not prepared or are not designed to be moved this way. For example, stateful applications, they are relying on persistent volume, which is bound to a cluster. So this kind of application for sure, if you want to migrate in this way, it involves downtime, because you have to stop the traffic in the old cluster. You have to do some kind of a disaster recovery. So do a backup, restore the new cluster and ship the traffic. So yeah, with these two main problems, it's almost impossible to do this in sustainable way for us.
This led you to investigate in-place upgrades with EKS. Many might think that this is just running a single command, but you found that it's more complex. What were your main concerns when considering in-place upgrades?
Yeah, so many people may have the perception that so in-place upgrade is a default behavior from EKS, right? And maybe it's just a click on the UI saying upgrade and that's it, or just one command line that you run like upgrade and that's it. But actually, there are a lot of things to unpack behind this process. So for me, I think there are two main concerns. when you are doing this in-place upgrade that you have to take into consideration. So the first one being the deprecation and removal of APIs that could break your existing workload once you upgrade. And this process is irreversible. So once you upgrade, you cannot go back. So this is an issue. And another big part of it is that when you do the in-place upgrade, what it means is that you have to replace all of the existing node pools or existing nodes to be updated to the new version. And normally this process, as we call full cluster rebuild, is generally where the problem occurs, involving downtime to the customer or some service degradation. So yeah, we decided to first take a look into this node rebuild scenario first out of the two problems, because not only it affect the cluster upgrade, but the full node rebuild also affect any operation that required full node rebuild, such as you want to change the AMI version of your cluster, you have to replace every node in the cluster. So yeah, we decided to take a look into this because it benefits both cases.
You ran some interesting experiments to understand the impact of node rebuilds on your service level objectives, or SLOs. What strategies did you test? And did you consider using Carpenter for this?
Yeah, so I will answer about Carpenter in the later part. But actually, when we were doing this, we were looking for a benchmark on how impactful each node review is. And the most obvious indicator that we could think of course, our SLOs, because they are actually a contract to our users. So if they are impacted, we know that our customer is impacted. So we try to run an exercise with different strategy to evaluate the impact on the SLOs during the rebuild. And I think the first strategy that we try was, I think we call non-serialized approach, which basically means that all of the nodes pool simultaneously got cordon. So it means no more workloads are placed into that. And then it spin up the new set of nodes with the new version. Wait until this new pool is ready, and then all of the previous one got terminated once the new one are ready at the same time. And of course, this is very fast because it destroy a lot of nodes at the same time. So I think if I remember correctly, it took like half an hour for a small cluster for us. But the impact to the SLO was, of course, detrimental because all the nodes are being destroyed at the same time. While the second strategy is more safe, which is a serialized approach, where only one node pool at the same time in the cluster got through the same process. So got cordon, recreated, and then destroyed, but only one node pool at a time. And the result is quite safe, so we have less impact to the SLO. But the problem with this approach is that it took more time. So if your cluster has a lot of node pool, it took hours to finish. But at the end, I think we decided to go to the serialized approach because we prefer to have minimal impact to the user compared to the time it takes to upgrade. And yeah, and I think by the end of the experiment, we take a look at the data and we saw the SLO that were affected, which mostly are ingress availability, ingress latency, locking latency, and DNS. So with this data, we were able to go into each component that was impacted that were underlying the SLOs, such as for ingress SLOs, we go into Nginx ingress controller, and we were able to kind of fine tune the configuration of the other underlying component. For example, we have to configure the proper graceful period for our ingress controller, so it's safe to destroy. We configure sufficient pod disruption budget and some kind of a minimum replica, so we can ensure that it's not highly impacted during the scale down. And yeah, after we fine tune this component and we reran the experiment again, and we found a huge improvement in terms of SLO impactation. So yeah, it's kind of safer when we configure this. And getting back to Carpenter question, actually at the time when I wrote this blog post, Carpenter was not as mature as today. So we were just looking at it, but we didn't use it. But as of today, when we have this podcast, we are already full Carpenter. So yeah, really help us in this upgrade scenario. So I think I wrote another blog post called the commuter effect, which cover everything that is related to this scenario. So yeah, I recommend checking it out.
Very good. We'll be sure to include that in the show notes. For many Kubernetes administrators, a major concern with version upgrades is API deprecation. How did you approach the challenge of ensuring your customers' workloads wouldn't break after an upgrade?
Yeah, so to get into this, there are two main fundamental things that we have to take into account. So the first one being the deprecation of the resource set itself. So it means that the resource inside the cluster that are going to be deprecated or are going to be removed when we upgrade to the next version. And another aspect is some kind of an API calls that the application is using at calling to the deprecated APIs. So yeah, the approach we use for this concern is that first we want to gain all the insights about these deprecations in form of metrics. So as a team, we envision some kind of a dashboard that show how many objects are going to be impacted in the next version, which objects are going to be removed, and what are the current API calls being made to these deprecated objects. So yeah, we did some research in the open source projects, and we found two tools which are the good candidates. The first one is called Kube-no-trouble, and the second one is Pluto. And they are basically like similar in a way that you can run this command line tool against your running cluster, and you get the data of what are the objects that are being impacted. But I think we went to Pluto because at the time it has more data set for us. And then what we did was we built a thin wrapper around this tool. So we get the result from the tool, and we built a wrapper to create a Prometheus metrics based on this data. And we call it chip deprecated objects metrics, where this objects has labels such as which cluster the object is in, which namespace the object is in, and which API group and version and the name of the object. So yeah, we can use these metrics to create the dashboard that we envision. And for the API calls scenario, there is already a built-in mechanism in Kubernetes, where if you make an API call to the object that are going to be deprecated or is deprecated, the Kubernetes will already annotate the API call with like deprecated true or something like that. And since we send all of our API server logs from EKS to Grafana Lokit, we can easily look up any API calls that has this annotation. So we can use this as part of the dashboard.
You mentioned creating dashboards similar to GK's insights. How did you transform this data into actionable information for both your team and your customers?
Yeah, so from both data sources that I mentioned earlier, now we can create that such dashboard. And for us as a platform team, so we can use it to answer a question like, are we ready to perform an in-place upgrade on this cluster safely? So in another word, it means that we see the dashboard and it has 0 objects that will be deprecated or removed in the next version. And there is 0 API calls to the deprecated objects in the cluster. So as the cluster maintainer, when we see this, it means that we are able to proceed to upgrade with confidence that nothing will break API-wise. But for our users, this dashboard is super useful as well, because we can also share with them a slice of this dashboard, as Ship is a multi-tenancy platform. So each user has their own namespace. So we provide kind of a slice of the dashboard with their namespace where they can look and see their deprecated objects, and they can follow the progress. So we tell them that, okay, we want to upgrade in this period of time. Here's your dashboard with your deprecated objects. Please take care of it. So it's kind of a self-service way of doing the upgrade. So this approach free us from chasing after everyone and trying to make them upgrade, right? This way they can track their own deprecation. And yeah, even though right now EKS now has the similar dashboard provided built-in, it wasn't the case when we were building this. But this slice version of the dashboard is still useful as the multi-tenancy platform, because from the EKS perspective, it's all the cluster level, but now it's tailored to each one that has the deprecation. So yeah, it's not such a waste that we invested in it.
Once you had all this preparation in place, how did you approach the actual upgrade process? Did you just dive in or take a more gradual approach?
Yeah, that's a good question. Yeah, of course, I mentioned these two main concern that we tackle, right? The node rebuild and the API deprecations. That ideally should tackle 95% of the problems. But of course, in production, nothing is guaranteed that nothing will go wrong, right? So, for example, I read this postmortem from Reddit where they upgraded Kubernetes from version 123 to 124. And even though they tested everything in dev environment, they still faced a big outage when they do this in production because some labels get removed from the control plane or the nodes. So yeah, it's always sane to do upgrade in phase in wave, right? So we use a concept of waves of clusters. So we define kind of a set of clusters that are less critical based on the workload that they host, and then we started from less critical clusters. We upgrade them first, and then we leave it for a day or two to make sure that everything is not going wrong. And then after that, we continue going to the higher critical clusters. And that is very that was a very good approach for us, because I think another thing that I learned from the Reddit incident was that nothing is like production, right? Even though you tested everything in depth and you are sure, but production is production. So in this case, we kind of get more confidence because we did the upgrade on production, but just less critical. And then we start gradually move to the higher impacted clusters.
After implementing these in-place upgrades, what benefits did your team and your customers realize compared to the previous blue-green approach?
Yeah, so for us, it freed our effort immensely, because as I mentioned earlier, normally an upgrade would take a whole quarter to finish with the coordination and with the preparation. And now it's only a matter of a week or two at most to finish. So all of this time that we save could be used to provide more features or to mature this mechanism better. And for our user, it also changed a lot their perception, because in the case that they don't have any deprecated APIs at all, for them it's almost seamless, because how it works is that we told them that your pod might be restarted due to the upgrade at this day, and then during the upgrade, their pod will be restarted and moved to the new node, and that's it. There were no action required from them. And compared to the past, where they have to work hand in hand with us and doing the traffic shifting together, now it's hand free. And I think, moreover, in terms of the benefit as from our team, I think we also gain confidence on the process, because we did it quite frequently, right, compared to the past, where we do it maybe once a year or something like that. And now with this frequent rollout, then we are doing it smoothly and we have more confidence on doing the same process.
Your article title mentions this is beyond the one-click update. Despite your success with in-place upgrades, you're still investing in blue-green upgrades too. Why is that? And what limitations or future improvements are you considering?
Yeah, so as of today, in-place upgrade is our default strategy for cluster upgrades. But of course, we still have the blue-green in our pocket, because this is what we learned from running Kubernetes at scale, is that the bigger the cluster is, the more problem is associated with. So for example, with having more pods, it leads to more bigger metric storage unit. It leads to more action on the reconciler. It leads to more congested network. It also introduced higher risk surface, because if one cluster with, I don't know, 1,000 nodes go wrong, then a lot of pods will be affected at the same time. So yeah, our experience is that a cluster shouldn't exceed like 300 or 500 nodes. That's the number we have internally from our experience. So once the cluster reach the number that we have, then it's time to do it blueprint and slowly migrating some traffic or some workload to the newer cluster.
In hindsight, looking back at this entire journey, what would you have done differently if you were starting this process today?
Mm. So I think most of the issues that we found during the upgrade, we were struggle a lot with the process that we use the node pool and this serialized and non-serialized approach. And this nowadays has been taken care of by moving to Carpenter. So I would definitely move to Carpenter before if I know that it would help this much. And I also would focus more on ensuring that the user have the same configuration of kind of pod disruption budget. So we can ensure that our customer is not impacted or has less impacted from the upgrade. So thing like ensuring that everyone has same default of pod disruption budget configured would be amazing. But that also comes with some caution that if you provide too strict of the default, it might block as well your upgrade. So I think this is the balance and the policy that you have to take into account. And yeah, I think lastly in terms of metrics, because I think having a metrics around how the node review is being done or how it behaves in correlation to SLOs impactation would increase our confidence on whatever we do in this area.
We recently had a guest, Matt Duggan, who suggested that Kubernetes should offer an LTS, long-term support, version to address some of these upgrade challenges. Based on the work you've done at Adevinta, do you agree with this perspective?
Yeah, of course, having LTS is a good option in general, right? Because different companies that has different needs, has different priorities, and not everyone has time to invest into upgrade mechanism. So yeah, a lot of people will of course benefit from LTS, and I think EKS now also has kind of a LTS offer with some increased costs, of course. But however, I think personally, I still will go with the pace of ensuring that you upgrade frequently, right? Because we were stuck in the past before. And with this new pace of Kubernetes version that it comes out every like 4 months, I think it's better to get familiar with the upgrade process and trying to mature your tooling, your process to be able to catch up. And one of the middle ground that my team and I have been working on is called double jump. So where, if possible, we will upgrade the version to two version at the same time. So it means that we upgrade, for example, from 130 to 132, and we only require one effort. And that is being possible by using Carpenter, which I mentioned also in another blog post.
You've written many good articles and shared your experience with the community. What drives you?
Yeah, so I think it's from my my past where I used to work in a like way smaller company and used to be just an engineer who enjoyed reading blog posts from like bigger company with the bigger scale, right? How do they do things? And now that I get to live in one of the like big platform or work in one of the big platform, it's on my passion to share this with other people. So it kind of remind me of me in the past who want to read about this interesting stuff.
What's next for you?
Yeah, I still have a lot of blog posts that I have an idea to write about. So yeah, I will try to work on that. And also now I'm interested in the AI and LLM, especially how it could help the work of SRE in day-to-day life. So yeah, I will try to write about them as well.
How can people get in touch with you?
I'm around in LinkedIn, so ping me anytime in LinkedIn.
Very good. I can definitely say from personal first-hand experience, it worked reaching out to connect with you there. Thank you very much for your time. Thank you for all the work that you're doing, sharing your knowledge with the community. And I hope that our paths will cross soon. Take care.
Thank you so much, Bart.
Cheers.